Welcome.
Hi.
Hi. Okay, folks, last time we talked about a bunch of functions, the algebraic functions, and today we'll talk about inequalities. If you don't know already, we're going to be using these once we learn derivatives to find out where a function is increasing, where it's decreasing, where it's concave up, where it's concave down. You've seen us already talk about these when we need to find the domain of something, so they're useful. And also, if you're into sort of competitive recreational math, you'll find also, if you want them to be useful, there's a bunch of sort of fun inequalities like Cauchy-Schwarz and arithmetic mean, geometric mean, if you've heard of any of that. So you can conceivably have fun with this stuff. Okay, questions before I start talking? More? Yeah?
Do you have a mic?
Okay, I've got that question several thousand times now. Usually you get that by accident, but you know. How's this? That's nothing, right?
No, it's not.
Okay. You know why? Because it's off. How's that?
Yeah.
Okay. Very good. Anything else? Tell me if it's too loud. Okay. Okay, here we go. Really, really simple. Here's an inequality. X less than 2. Yeah, seriously, if you know this, don't worry. Okay, x less than 2. On the number line, all x less than 2. Is that familiar? Any questions about this? Yeah? This means exclude, and we go everything less than that. Yep? Okay. X greater than or equal to 3, or minus 3. So that should be 2. That's the number line. Include minus 3 and everything bigger than it. Okay? All right. Helpful facts about inequalities. Helpful effects. Results, theorems, laws. Number 1. If A is less than B, then A plus C is less than B plus C for any number C. Okay, so you can add any number to both sides of an inequality and it still works. Good? Any number. 2. If A is less than B and C is less than D, then A plus C is less than B. So if I turn my head, you get more amplification, huh? Good. Okay. A plus C is less than B plus D. Okay, so all I did was add those two inequalities. So this tells you can add inequalities. Okay? 3. Tell me how low I can go before you can't see. If A is less than B and C is positive, then we can multiply both sides by C and still have everything be the same. Okay? So you can multiply both sides by a positive number. If A is less than B and C is negative, then CA is greater than CB. Okay, so if you multiply by a negative number, then you got to flip this. Okay? Do not forget this. Okay? And finally, can you see down here? No. Thank you. And finally, if A less than B, where both of those guys are positive, then the reciprocals switch order. Is that how I want to say it? Okay? If A is less than B and they're both positive, then the reciprocals have the opposite order, but they're still positive. Okay? For instance, 2 is less than 5, I hope, but a fifth is less than a half. Okay? And if you care about the negative version of this, I'll tell you the negative version of this. Do you care about the negative version of this?
We need to know.
You know, if I just keep telling you stuff, then you can't complain, right? Okay, here's the negative version. It's the same deal. Okay, if they're both negative and A is less than B, then the reciprocals are still negative and the order flips again. Okay? You can try that with -5 and -2 or something. Okay? And if you want a picture that tells you why this happened, you look at graph. That's what 1/x looks like, right? On any subinterval of its domain, it's decreasing. Okay? And that pretty much makes that happen. Good? If this, then this. Which is pretty much what we said for decreasing functions. Say if you have a question. Okay. All of these kinds of things also hold if you have equal signs, right? You can add equations, you can add things to equations, you can multiply both sides of an equation by a number, right? So all of these guys also hold for weak inequalities, okay? Also hold for when you've got greater than or equal to and less than or equal to. Okay? Well, let's say just that. Okay? Except those ones. Okay, so the kinds of things that talk about being positive or not, don't change those. But everything else you can replace with less than or equal to and still get truth. Okay? So for instance, this is also true. Okay?
So for number 5, like the helpful fact, like basically that inequality is specifically for like y equals to 1/x, or like
No, I'm saying,
fraction.
yeah, go ahead.
like any fraction like function, or
This is true anyway. This is true for numbers, A and B. Okay, so if you take the reciprocals and they're both positive, then the bigger number gets the smaller reciprocal. That's it. I don't even know who I'm talking to if someone said something. Is it you? Okay. I'll face you more often. I probably won't. This is to illustrate maybe why you can understand if that's true. Okay, so this is for numbers.
okay.
And if you want to see why, maybe that helps you see. Okay? Okay. Sorry, it's not every day you hear your own breathing. Okay. Do I want to do this? Okay. Easy one to start. Okay, I've been told I'm forbidden to write over there and over there, so my writing region is small. Example. Solve. Again, they'll get harder, I promise. And if this is hard, then they'll still get harder. Okay, minus 3 is less than or equal to 9 minus 2x is less than 7. Okay? Shuffling cards. Okay, when I say solve an inequality, I mean find all x that satisfy it. Okay? Okay, now you can sort of do this all in this kind of form, or you can break this up into its two inequalities and then do them and then combine them. Okay? Suppose for now this is simple enough that we can just do it in place. So, what can we do? We can add minus 9 to both, I said both sides, to everything. Okay, add minus 9 to everything and you get this. Okay? This is a double-headed arrow, meaning if and only if implies and is implied by is equivalent to any of those things. Okay, because when you're trying to solve something, you better only do reversible steps, otherwise you're either losing information or something like that, and you don't like that. Okay. Divide everything by -2, or multiply everything by -1/2. And what must I not forget to do? Right, everything flips, okay? Good. Right, so multiply everything by -1/2. Flip me. Flip me. Okay? Please, please don't forget. And if you forget, in this case, I think you get nonsense. All right? Okay, and that's it. So that's your answer. 1 is less than x is less than or equal to 6, or you could say x is in this interval. And that's it. Okay? Yeah.
What causes the sign to flip?
That's a great question. What causes it? Well, if you try, suppose you just try some numbers in here, would that be convincing enough, or do you want a deep explanation? So suppose you had, I don't know, 2. Okay, so suppose you had 2 less than 3, right? I do actually have an answer. Yeah, I'll give you an answer after this. Okay, 2 is less than 3, right? If you suppose you negate them both, this is now the smaller one, right? I think unnecessarily complicated way of looking at it would be that negation is a decreasing function, essentially, so that would...
Good answer.
Okay. Thank you. Okay, good. That's it. Okay. So if you want to see this thing on a graph, all right. -3. 1. Probably not to scale. Okay. Y, x. Okay. this guy is this guy, okay? This is the graph of y equals 9 minus 2x. We want that thing to be between minus 3 and 7, so between these two lines, and that just maps to x being between 1 and 6. Ta-da. Good? Okay, and I'm not going to do this for everyone, but if you want this on a number line, and Wolfram Alpha loves to give you these things on number lines, you can do that. Okay, don't include 1, do include 6, and go into 2. Okay? Alright, if you ever want to practice this stuff, or quite a lot of other things, you can use, online graphers, you can use Wolfram Alpha, okay, carefully, to check stuff. And I do mean carefully. Anything? Good? Okay, example. It's almost all examples today. Solve 2x squared minus x minus 3 positive. All right, what do you do first? You could do that, yeah. Or factor it, yeah. Anyone know this already? It's easy for me because I do them backwards, so I know what the factors are already. Okay. Know how to factor stuff. Okay, so you can factor it as that. Okay? And again, equivalent. Okay, now how would you do this? Who's got a way? Yeah.
Can you separate it into two cases, one for each factor?
You could do, yeah. Did you want to say something? Same thing? Okay. Okay, I'll show you a bunch of ways, and hopefully I won't do all of these ways for every problem. Okay. We'll do her way. Two cases meaning, okay, so here's what I would have done. I would say the only way to have a product of two things be positive is either they're both positive or they're both negative. Is that the kind of thing you do? Okay. Right, again, so this is the algebraic way. The only way to get a positive product of two terms is to have them both be positive or both be negative. So case 1, 2x minus 3 is positive and x plus 1 is positive. Okay, and then go for it. And comma means and, okay? Okay, that's the same as saying x is greater than 3 over 2. And that's the same as saying x is greater than negative 1. If x is greater than 3 over 2 and x is greater than negative 1, that's the same as saying that. Okay? Any questions about this thing? Okay. And if that's really confusing, you can draw that on a number line and you'll see where things overlap. Okay. Is this too low?
Yeah.
Yes? Brilliant. Okay. This isn't 2, this is just case 2. Okay, or they're both negative. Okay, so that just means x is less than 3 halves, and that guy just means x is less than minus 1. Okay, so x being less than minus 1 and x being less than 3 halves, that's the same as x is less than minus 1. Does that make sense? Okay. Again, commas mean and. Cases are or, right? Or. Okay, so either that happens or that happens. So there's your answer. X is less than minus 1, or x is greater than 3 halves. Good? Okay, that's one way. If I erase something that you're writing, please scream. Maybe I'll get rid of this thing. if I know how to get it back later. Okay, another way. Who has another way? Nobody. Okay, here we go. So the second way is graphically. Okay? Can you graph this thing? This thing. So that's a parabola, yeah? Does it open up or down? Up. Good, excellent. That's positive, so it opens up. Its zeros are, or its x-intercepts are 3/2 and -1. Okay? So this is the graphical way. -1 and 3/2. And it opens up. I will occasionally get lazy with this XY labeling. Okay, that is that guy. 2x minus 3, x plus 1. Good? Okay, you want that thing to be positive. Okay, check it out. So you want it to be positive, it's positive here. Here, and it's positive here. X less than -1 or x greater than 3/2. Good? Okay. Okay. All right so far? Third way, which I'm sure has to go up there. Now in my head, that's a lot simpler to think about than the other one, right? As far as I'm aware, a lot less work. Okay, here's another way. You look at the factors and you look at them on intervals. So, you're kind of thinking of this. So let's see what we need to solve again. We need to solve that. We're solving 2x minus 3, x plus 1 positive. Okay. So, the intervals, or how to put this, the points where this thing can change sign, okay, are just the zeros. Does that make sense? Okay? This guy is only going to change signs at its zeros, which are just the zeros of these guys. Okay? For instance, which is, I think, a kind of format that would be familiar to you if you've done derivatives and increasing and decreasing and all that stuff. Okay? So again, this is a nice, friendly, continuous function, which is a word you don't know yet officially. And so the only time this is going to change sign is at its zeros. Okay? And the zeros of this are 3/2 and -1. So let's look at its sign on each of those pieces. Does that make sense? Okay. 2x minus 3 is going to be negative until you hit 3/2. This guy is going to be negative until you hit -1. Their product, a minus and a minus, make a plus. A minus and a plus, make a minus. A plus and a plus, make a plus. You want to know where this puppy is positive. Positive, positive. And that's it. Okay? Yeah.
What's like your preference for how we would write that in like a therefore statement?
In a what?
Therefore
In
statement?
a there. Just at the end? You just write therefore.
Like,
You mean an interval or not?
f of x is positive, is like greater than -1, or than 0.
I have a feeling as long as you're right, we won't care.
Okay.
Is that what you mean? Yeah, so at the end, you'd write something like, therefore, x is less than -1 or x is greater than 3/2. Is that what you mean?
Yeah, like f of x will be positive.
Or just 'cause
Yeah, because we said solve this, right?
Some teachers get like finicky about it.
I suspect if you're right, you'll be fine. Yeah, so if we're saying solve this and you just write that or that, you should be all right. Unless we say write it in interval notation, in which case, just write it in interval notation. Right. Yeah.
Can you show us how to write it in?
Yeah. Okay? Less than -1 or greater than 3/2. Okay? And if you want to do this way, but you don't feel like thinking too hard, then you can just pick a number that's less than -1, plug it into this stuff, and then see what its sign is. Okay? Really brainless sort of calculatory way to do that is to just plug in numbers that are in the Okay? Okay. Example. Slightly hairier. Solve. X cubed less than or equal to 12x minus x squared. Okay, play with that while I puzzle over this thing. All right, what would you do? Yeah.
Bring, subtract each side by x cubed, and then, well, technically, and then multiply by -1, or you could just bring the other side.
That's right, exactly, yeah, good. Either side, you can figure it out, yeah. Good, excellent. So, let's write this in a way we'll maybe recognize it. Good. Fair? Bring those guys, bring everything to the same side. Okay? So we can talk about it the same way we talked about that guy. Okay? Okay, what's next?
Factor out the x.
That's good. Anyone else? If anyone disagrees with anything, you can say so. Factor of the x is good. Right? Because someone was friendly and gave us a nice cubic. Again, all of these are if and only if it, and only if and so on. Good. Next? Factor is good. Factor, or if you're
X plus 4 and
x plus 4 and x minus 3, yeah. Thank you. Okay, good. All right, or if you're feeling, like killing some time, quadratic formula. Okay? Now what? Yeah, you go, and then I'll come back. Yep.
Can you just put it into the factors table like you did before?
That kind of thing?
Yeah.
That'll work, yep. Good. And what were you going to say?
there's one of the three.
One of the three, that's right. Either way. Good. So, okay, let's try some of the ways again. Goodbye. Okay, so what do we got? What are the zeros of this guy? 0, -4, and 3. Okay, so... Okay. This guy becomes positive here. This guy becomes positive at 0. This guy becomes positive at 3. Or think about that however you want, or plug numbers in and see what you get. And so... minus times minus times minus is minus. This is plus. This is minus. This is plus. And what did we want? We wanted less than or equal to 0. So the ones we care about are these guys. But it's less than or equal to, so include the change points. So write x less than or equal to minus 4, or x between 0 and 3 inclusive. Okay, good? Okay. Or we could try the other ways. And I'm going to show you these ways a few times, possibly the last time. That's our third way before. The graphical way. What does this guy look like? It's a cubic. Its zeros are at minus 4, 3, and 0. Okay? And that means it looks like this. Okay? Now how do I know that it looks like this and not say like this? Somebody said at the front? Sure, yeah. You can look at the coefficient here, or you can just think, what happens if I put a really big number in, right? A really big positive number in. That'll be positive, that'll be positive, that'll be positive, so it's up there. If I put in a really, really, really large negative number, that's going to be negative, that's going to be negative, that's going to be negative, and so down. Okay? Does that make some sense? Okay, so you can figure out which way this thing points. And you want this thing non-negative. I mean, sorry, not non-negative, you want this thing non-positive. So that's down here, and here. Same answer. Less than or equal to minus 4, or between 0 and 3 inclusive. Okay? If you try to do the case thing, the way we talked about before, you're probably going to have to say something like this. Either all 3 are non-positive, right? Yeah. Either all 3 are non-positive, or 1 is non-positive and 2 are non-negative. Okay? And that's going to break up into 4 cases. Okay? Which is a pain. Okay? So you could be slightly clever. So again, you could do the case thing, except it's 4 cases. But if you think for a second, we're lucky and we don't have to do that. Okay. So again, one possibility is that all 3 are non-positive. Case 1. Okay, that's one possibility to get this thing. Now what you could do is you could think. Again, you want 2 of them. The other case is that 2 of them are going to be greater than or equal to 0. And 1 of them is going to be less than or equal to 0. But this is everywhere bigger than this, which is everywhere bigger than this. Okay, so the only way that's going to happen is if these guys are the non-negative ones, and this guy is the non-positive one. Okay? Again, if you don't think of that, then you just do all the cases. Okay, and the other 2 will fall apart. So what's this? This is this guy, and this guy. Okay, less than or equal to 0, 3, and minus 4. That's all just like saying x is less than or equal to minus 4. What's this? Okay, greater than or equal to minus 4, greater than or equal to 0, and less than or equal to 3 is the same as x is between 0 and 3 inclusive. Ta-da! Good? You could do that. Whether you really want to be doing that is another question. Okay?
Can you explain the last step, please?
Which one?
Like,
This one?
Yeah.
Okay. X is both greater than or equal to minus 4 and greater than or equal to 0. That's the same as this. This is more demanding. Does that make sense? Okay? How do I put this? If you do this, you've automatically done this. That's basically it. Or you can draw them on a number line and see where they overlap. And they'll overlap here. And this just say this. Okay? Yeah, convince yourself with a number line or just by thinking about it, that these two combine to make that. Yeah.
Do you have a preferred method of solving it?
No, just do something that works and well and fast. If you know all of them, then maybe in a given situation, one might be better than the others. Sure. Okay? Okay. I just did that to show you that it works, okay? Pick something that you like. Okay, questions? Okay. I'm going to pretend I didn't just erase the one board I wanted to keep. No questions, yeah? Okay. We're going to talk about transformations, more than the 2 seconds we talked about it today. This is another sort of transformation, taking the absolute value of a function. So let's talk about that. Example. The absolute value of the function we were talking about. Okay, suppose we want to graph this and we want to describe it piecewise. Any thoughts on how to graph this? While I reproduce what I did before? Okay. Ideas? I'll go there because I'm not talking to you a lot. Yeah.
Just take out negative,
Yeah, and do what to it?
make it positive.
Make it positive, that's it. Yeah, okay, good. Okay, so, what can I erase? Okay, the absolute value of f at x is going to be just f at x if f at x is non-negative, and it's going to be minus f at x if f at x is negative. Okay? That's how the absolute value works, right? Okay. This is just the function you started with. This, and we'll talk about this officially later, is obtained by flipping the function you have over the x-axis. Okay? This thing. Right? Okay, so you can get the graph of negative f by flipping the graph of f over the x-axis. Okay, so let's look at this thing. The graph of this is just going to be the graph of this, but with all the negative stuff flipped. And that's it. Okay? So, if I call this f at x, that's the graph of f. That bit's negative, so let's reflect it. Let's keep the non-negative stuff. That's negative, so let's flip it. And let's keep the non-negative stuff. And that is the graph of the absolute value of f. Okay? You rectify the graph, the signal, whatever. Okay? Everything now becomes non-negative. Does that make sense?
You reflected it through the y-axis or the x-axis?
Across the x-axis.
Oh,
Good? If it was, the minus was in here, then it would be this one.
right.
Yeah, okay. Okay? And sort of you don't know that yet, but I guess a lot of you probably do know that already. Questions? Okay. And I said let's try to describe this piecewise. So, there's green. Okay, so you could write this. Essentially this. Okay, this guy is just this guy's absolute value is just itself if we're where? Between -4 and 0. Or over here. So greater than or equal to 3. And it's negative. You flip it and make it positive if everything else. You could write otherwise here and make your own life easy. But I don't do that. Make sense? Okay. Questions?
Why
Yeah.
wouldn't be less than equal to?
That works too. Because that -4 is just 0, so it doesn't matter which one you put. Okay? Good?
Would you mind writing a bit larger?
Yes. I mean, no, I wouldn't mind. You guys like everything bigger. I apologize, I will try. Okay. All right, for fun. And if there's time at the end or whatever, you can just come talk to me anytime about this if you want. Try these. Try solving. Too low already. A. 3x cubed minus x squared plus x plus 2 positive. 3x cubed minus x squared plus x plus 2 positive. And for those like me who don't know how to factor that sort of thing, I'll tell you what it is. 3x plus 2, x squared minus x plus 1. Okay? Incidentally, last time I talked about the rational root theorem, and talked about it somewhat sketchily. I wrote something up. Who wants something on that? It's optional, totally optional. I can post it if you want. Who wants me to post it? All right. Might as well. Is that fair enough? How about I post it and you don't have to look at it? Is that all right? Okay. All right. In case you're wondering of a possible way of thinking about how to factor this thing if you don't know how to, okay? If ever you had to factor something like that. Okay? What's that?
Will we get problems where we need to?
No, I think if you did, this would be officially part of the deal. You do not have to look at it if I post it, okay? And if I don't post it, please don't look at it. Because that would probably involve a break-in of some sort. I'm regretting saying this now. Really regretting it. Put it this way, to factor stuff like this, you can use the rational root theorem, okay? And if I do post something, you don't have to look. Here's the second one. Okay, and similarly, if you want this thing factored, okay? Try those if you want, or come talk to me at the end, or come talk to me anytime and we can talk about them. Questions? All right, what do we have? Yes, I think if you had to solve stuff like that, it would be in the official curriculum, right? It wouldn't just be stuff that I keep saying on the side. Okay. Example. Find the domain and range of that. So, except no, let's be good. Of f, where the square root of 2x squared minus 8. That's probably too small, right, for the people who are upset with me. Okay? What do we do? Yes.
Find the value in terms of y.
Yes. And what has to happen for this to be in the, let's say for the domain, what has to happen?
Has to be greater or equal to 0.
Great. Excellent. Okay? You can think of that composition thing. It's a composition of two things, right? On the inside you've got this guy, on the outside you've got this guy. This guy will be happy no matter what you give it, okay? This guy's domain is everything, okay? You can give polynomials whatever you want. So you're really concerned about the square root, okay? And even roots only take non-negative inputs. So 2x squared minus 8 must be non-negative. Just see if I did anything I didn't want to do. No. Okay, what's next? There's a load of ways of doing this. I'll do the easy bit. Okay, what would you do?
X plus 2, x minus 2.
Yes, now,
That is.
those are the zeros, yeah?
Yeah.
And then you have to figure out, yeah, okay. Good, so you can do that. So you can essentially do this, and do all the usual stuff we talked about, okay? You can do that. Okay, all the stuff we talked about before, right? The interval thing, the graphical thing, the algebraic thing. Or, suppose you just write this. Now, can I do this? Take the square root of both sides. Is that upsetting, or is that okay? I don't know, I can't hear it. That's okay. Okay? The reason that's okay. Well, first of all, the square root is okay with all the stuff that's in here. Everything here is non-negative, so it's fine. The square root function is increasing. Okay? Square root function looks like that, right? It's increasing everywhere. So if you apply it to an inequality, it stays as it was. Okay? It's strictly increasing, so it preserves the inequality. Okay? Which is almost how we define increasing anyway. Okay? Okay, so if you want, you can just recklessly apply square root, or you can think, yeah, it's in the domain and it's increasing, so we're cool. Okay? Now, if you've done a decreasing thing here, then you'd have to flip the sign. Does this make sense? Doesn't make sense. What doesn't make sense? And thank you. Yeah.
So it keeps on increasing. Is that because the domain is strictly positive?
For non-negative. For the square root. So this was just supposed to be the graph of the square root of anything.
Okay, so then when would it be decreasing?
Nowhere. This guy is nowhere decreasing, right?
Oh, okay, so you're talking if it's a completely different.
Yeah. Pretend all this never happened and look at this. Thank you, yeah. Okay? Good. So when you take the square root of something, that operation is an increasing thing. Okay? And increasing things preserve order. So if we've got something like this, I can take the square root of both sides and not screw anything up. Okay? That's the underlying reason. You don't have to worry too much about that. You can do this, that's the point. Okay? Okay. Okay, now what's the square root of 4, guys? Thank you. What's the square root of x squared?
X.
Whoever said x gets a slap. And again, x squared and the square root are not inverses, okay? X squared doesn't have an inverse. Okay, x squared restricted, which is this guy, does have an inverse. You flip, hey, you get this guy, right? So x squared restricted has that inverse. So you can indeed say that the square root of x squared is x if x is non-negative. That's cool, okay? But if you want to take care of everything, then you got to put absolute values around it, okay? And if you want to figure that out, there's a bunch of ways of figuring it out. You can look at graphs, you can just plug in numbers, negative numbers in here and see what it looks like, okay? Nothing weird, all right? Just don't forget this if you want to do it this way. Absolute value of x greater than or equal to 2. At this point, maybe you're just saying, okay, the size is at least 2, so it's either minus 2 or less, or it's 2 or more. So you can just say that at this point. Does that make sense? The size of the number is at least 2. That's it. Okay? And that's exactly the answer you'll get if you do this by any of those methods. Okay? Or you could graph the absolute value function and see where it's above 2, and you'll get that answer. What else can you do? You could go nuts and break this up into x is non-negative and x is negative cases and then go. You could try this on the number line, and I think that's it. Okay? So again, do this how you like, but this makes sense and it's quite convenient if you understand this. Okay? All right. Questions? Okay, what's the range of this thing? Someone raise a hand and then talk. Yeah. Yeah, or equal to. Excellent. Okay, good. So if I stick in a plus or minus 2 into this thing, right? The x squared will be 4, 2 times that will be 8, minus 8 is 0, the square root of that is 0, so I'll get 0. Okay, a square root can't spit out anything that's less than 0. Okay, it can in this case spit out 0, and if you put in an x of sufficient size, you'll get any number you want that's greater than 0. Okay, so the range is, okay, this was the domain. So, no, let's write this properly. Okay, so the domain here, write it however you like, is everything up to minus 2 and everything after plus 2. Okay, and the range is the non-negative reals. Okay, again, because this can't spit out anything less than 0. It does spit out 0, for instance, at these 2 points, and only at these 2 points. And if you put a big enough x in, then you can get anything else you want that's above 0. Okay? All right. You guys heard of spaghetti code? Have you read a computer program that has go-tos and just jumps around? That's what my notes look like. On the page I really wanted to get to, so that's good. Any questions about any of this? Okay. If you're freaking out, let me know. Although maybe I've noticed. Okay. Example. If you looked at the homework, this will look familiar. And again, for any of this stuff, okay, if you put it in, for instance, Desmos, which is written like this, that's a graphing calculator online, and it shows the right thing. Okay, sometimes I tried it with Wolfram Alpha, and it knows about imaginary numbers, and so it does upsetting things sometimes. You have to be careful. Okay, but this is pretty good if you want to check stuff. Okay? Okay. So, f is this, g is this, and I say, guess what? Find the domain of f circle g. All right, what do you do first? If you want to be really systematic and good. What do you check first? X has to be in the domain of which one? Perfect, thank you. Okay, so, exactly, and thank you. So G is applied first, while written second, and so X has to be in its domain. X has to be in the domain of G. And I'll write it like this, but think about it however you like. You can think X makes G happy if you like. Okay, what's the domain of G?
Greater than 2.
What's that?
Greater than 2.
Not 2.
Not 2.
That's it. Don't divide by 0. That's the only thing this guy says. Yep? Excellent. Okay, so X can't be 2. Okay? All right. Next thing. G of X has to be in the domain of F, right? And again, it is possible to do this less systematically, but systematically you understand what's going on and you're less likely to make mistakes. You want G of X to be in the domain of F. So that guy has to be in the domain of F. Okay, what's the domain of F? What does X have to, what the F? Okay, what do you have to do to make F happy?
Greater than 0.
Greater than or equal to 0. Yeah, this bit has to be greater than or equal to 0. So X has to be what?
Greater than equal to.
Greater than or equal to 4. Very good, okay, good. So the thing that you feed in here, which in this case is Gx, has to be greater than or equal to 4. And again, that's an inequality, right? You could write x minus 4 greater than or equal to 0 because it's an even power, an even root, and so you get x greater than or equal to 4, and that's that. Okay? Okay. All right, what do I do now? And by the way, this is sort of taken care of already, but yeah, it shows up here as well, right? You still don't want to divide by 0. Okay, what do I do now? We're in inequality land. Yeah.
Can you just solve for x?
You can. What would you do first?
Multiply 4 by x minus 2.
Yes. Yes. Now, who wants to scream now and say something horrible has just happened? What am I doing that's bad and bad and bad and very bad? Yeah. What's that? You said something about greater, right? Say it one more time. It doesn't matter. Is that roughly what you said?
I thought she was losing information because like
Essentially, yeah.
yeah.
To be fair, you didn't actually make a mistake because you said nothing about this guy. So, I'm not saying you made a mistake. Yeah, but don't just write this. Don't just go, all right, I'll just multiply both sides by x minus 2 and that's cool. Okay? You've got to do cases because what if this guy's negative? Then you've got to flip this around. Okay? Don't forget that. So, case 1. And you'll see, if you don't do this, you'll get a different answer. Okay, so case 1 is that x minus 2 is positive. Okay? In that case, you're okay. Just carry on. Multiply both sides by this and keep the inequality in the same direction. Okay? Okay. It's all easy and good now, right? 4x minus 8. Sorry, I'm not sure what I'm worried about right now. Nothing, right? Does it make sense that we care about this being positive so that we can keep the inequality in the same direction? Does that make sense? If it doesn't make sense, say. Does it make sense that this is the same as this? Okay. And does it make sense that I definitely didn't say anyone did anything wrong? I did it wrong on purpose to prove a point. Okay. Add 8 to both sides. Divide both sides by 4. Do I have to flip this sign or no? No. 4 is positive. Good. 9/4. There you go. Okay? So So bring these two guys together. They're both part of this case. X has to be greater than 2, and X has to be less than or equal to 9/4. Okay? Questions? Okay, the other case is what? And by the way, this speaker thing is working, yeah? You're okay. I know that it's making unwanted noises, I just don't know if it's producing good ones too. Case 2. X minus 2 negative, or X less than 2. Multiply the inequality through by that, but this time make sure you do this because we're talking about the negative guys, right? You're multiplying by a negative number, and so you've got to flip the sign, or the direction of the inequality. 1 less than or equal to 4x minus 2. Okay? And then keep going. 4x minus 8, add 8 to both sides. X greater than or equal to 9/4. Okay? All right, bring that guy to that guy. Don't forget to include this thing. Okay? X less than 2 and X greater than or equal to 9/4. What is that? Tricksy. It's bad. It's nothing. Okay? You can't have X be less than 2 and be greater than or equal to something that's bigger than 2. That doesn't make any sense. Okay? That guy is talking about this. This guy is talking about this. You can't have this and this at the same time. Okay? There's no overlap. Okay? So, nothing. Impossible. So your only option is this, and this is the answer to the question. Okay? Where are we? Okay. Let's look at this case for a second. Let's look at the graph of this thing. Okay, again, we haven't technically talked about this yet, but 1 over x looks like that. That's it shifted to the right by 2. So it looks like that. Okay, and we're saying that, sorry, I'm not saying this is the composite function or anything. I'm saying this is just to figure out what this is. Okay? All right, so this is, okay, and you want to see where this guy is greater than or equal to 4. So 4 will be up here someplace. Okay, greater than or equal to 4 is all of this. Okay? Don't include 0 and do go up to 9/4. Good? Questions? Okay. If you want to write it as an interval, obviously you write it as an interval. Okay. Unless I've skipped something, this will be my last one. Last example. And again, once you figure out the domain of something, you can always graph it. Get a computer to graph it and see if the domain you thought is actually the right domain. Okay, possibly final example. Solve minus x plus 3 less than the absolute value of 3x minus 2 less than or equal to x plus 2. Okay. Ideas? Yeah.
Absolute value, so you have to separate it into 3x plus, or minus 2 is negative, and 3x minus 2 is positive.
Sounds great. Good. Excellent. Okay, you see this. One of the things you can think is, yeah, I probably need cases for this. Okay, excellent. So case 1. is that the guy in there is non-negative. And that's the same as saying x greater than or equal to 2 over 3. Okay? In that case, what winds up in here? Just the function itself. So you've got minus x plus 3 less than 3x minus 2 less than or equal to x plus 2. Okay? All right, now what? We'll just say solve, right? Okay, so if you're, you might do this all in place. I found it nicer to break it up, so you can break it up into its 2 pieces. So here's one piece. And okay? By the way, I just made this as weird looking as possible, okay? Not as possible, but I've tried to make it weird looking. Okay, that's okay so far? Okay, let's go. So let's add x to both sides. So we got 4x. Let's add 2 to both sides. X is greater than 5/4. Over here, let's subtract x from both sides. And let's add 2 to both sides. X less than or equal to 2. Please tell me if I make a mistake here, it's a bit hairy. Okay? All right, x bigger than 5/4 and x less than or equal to 2. Is that okay or not okay? Okay? Not okay? All right. What an election that was. I looked at you this time. Last time I didn't look at you, and there was no result for some reason. Okay, 5/4 is here, 2 is here. You want x less than or equal to 2, and x greater than 5/4. Where do they overlap? Here, right? They overlap here. Okay? Everything's fine in this case. 5/4, you probably can't see down there. Five quarters is less than x is less than or equal to 2. And what else? Never, ever, ever forget this, okay? So that's not all there was. There was also this guy. So, remember, include this and include everything you discovered. Where's 2/3? It's over here someplace. Greater than or equal to 2/3. This is ridiculous. Let's do this again. 2/3 is over here. 5/4 is over here somewhere. 2 is over here somewhere. X greater than or equal to 2/3. You can't see, can you? Can you see?
Yes.
Who can't see? Okay. 1 is good enough. Let's go over here. 2/3, 5/4, and 2. Okay, you've got to be at least 2/3 to get on this ride. You've got to be bigger than 5/4. You've got to be at most 2. Okay, where do they all overlap? Just what I said before. Okay? 5/4 less than x less than or equal to 2. Okay? Okay. Okay, again, make sure you combine stuff properly. If you need to use a number line, use a number line. It is totally possible to do these in your head and come up with that, okay? And please don't forget this thing, okay? So combine that and everything down here. Okay, case 2. Case 2. That guy negative. Okay. So the absolute value of 3x minus 2 and 3x minus 2 is negative. It's just minus 3x minus 2. Okay? Almost there. Yes, ma'am.
Why didn't you write less than or equal to?
Where did I?
For x is less than 2/3?
Yeah, here?
Yeah,
Why did I not?
yeah.
Because I sort of settled the equal case here, so I figured I would. It doesn't matter. You can do it twice because it's the same. There, it doesn't matter. Cool? All right, so here we go. Yeah. Minus 3x plus 2. Part of the point of this problem is to make me suffer a bit so that you guys can watch that. Okay? All right, again, break it up into the two pieces. Minus x plus 3, less than minus 3x plus 2. Minus 3x plus 2, less than or equal to x plus 2. And then solve as normal. Okay? And again, if you ever have to divide or multiply by something negative, remember to flip, okay? I'm sort of moving things in a direction that avoids me having to do that. Okay. Okay, add 3x to both sides. So you get 2x over here. Subtract 3 from both sides. Okay. Divide by 2, and you've got that. X less than minus 1/2. I hope. Good. Over here, add 3x to both sides. And the 2's canceled. Okay? Excellent. Good? Okay, this guy, and don't forget this guy. Okay? So let's look at them and see what they tell us. Does anyone know the answer already? Look at these two. I want x to be greater than or equal to 0 and x less than minus 1/2. That's nonsense. Okay? Can't have something be less than a negative number and greater than or equal to 0. Okay? So it doesn't work. Okay? So even without looking at that third guy, it just doesn't work. Impossible. Okay? You can draw number lines to prove that to yourself if you want. Okay? So, the answer to the question is just that, because that case was impossible. Okay? And if this guy's still alive, I'll show you a picture. And if it's not, then I won't. Give me 1 second if I can figure out what the lights are. No, that's a thing. Do me a favor, just keep your hands to yourselves and just give me a second. All right. Look at the gorgeous coloration on this. Okay, good. All right, just look at that. You could have graphed this and look at that everything makes sense, right? So you want that black guy, okay? The absolute value of 3x minus 2, to be between the red one and the green one, and the red one has to be beneath, okay? We said minus x plus 3 less than, absolute value of 3x minus 2 less than or equal to x plus 2. So you want this bit here, okay? You want the red guy on the bottom, you want the black guy in the middle, and you want the green guy on top. And that you'll find is exactly the region we found. Okay.
Why is it then including two?
What's that?
Shouldn't it be like just less than two?
But I've got this. Where's my actual original thing? I don't have my original thing. Good. My original thing has a less than or equal to in it. It has that. That's why. And that filters through somewhere and makes that
So
happen.
then it's when the black line and the green line from where they meet and down.
That'll be it, yeah? 'Cause it's, yeah, and then but exclude this point, I think. Yeah.
Okay.
Okay, does this make sense? You got any questions about this, let me know. There's a bunch of little tricks you can use with absolute values. Look, technically we're done, okay? You're very free to go. If you want, I'll write a few of these things on the board. If you don't know them already and you can use them, they're straight from the book. Otherwise, you're totally good to go, okay? Or if you want any of those try this for fun things, you want to talk about that for a second. Talk to me about that, okay? So I'll keep writing, and if everyone marches out, I'm totally cool with that. This does not matter.
Oh, I kind of get this, because I don't remember doing this.
And that's less than negative one half.
Oh, that, yeah.
But it can be less than negative one half and less than 1/3.
So why didn't you circle this?
Was that to me?
Oh, okay, yeah. I'm so confused, okay. Never mind, having flashbacks. We do, but they're online.
Let me just read this last sentence.
Yeah, I'm gonna do textbook first. I kind of get the switch. I get the open the bag, the center switch. Yeah, I understood this. Finally understood. Like, it is simple, so you can move it.
Did that happen?
Negative, so it's like this pure like flip. That's what I get.
Okay, that's okay. Those are occasionally convenient, if you want to write them down. Any questions from these people? Unless you want a picture of me, in which case you can have that. Okay.
Yeah.
Yes.
Right here.